Okay, so we're going to go into what we're learning now to take care of that problem. We have a new formula and it's for integration by parts. Integration by parts. Okay, so here's the formula. Now I know it's going to look a little bit foreign to you, and that's okay. As we do examples, it'll all make sense. So here's the formula. We integrate u dv. Now I know already you're going, well, wait a minute, that's a u and that's a dv. How can we do that? Okay, so just let that pass by for a minute. So it equals uv minus the integration of v du. Now at this level, you don't have to derive the formula. You're lucky you just get to use the formula. So yes, you need to have this memorized. Okay, integration by parts formula. We'll be using that a lot today. Now, a key that I want to give you, a little hint, is if we start off right away and we list off to the side u, du, v, dv, it'll make the process a lot easier. Now what we want to start doing is finding our u and our dv. So the first things we will do is we will split, when we get a real problem, we will split and call one thing u, I'm going to put a little arrow there, and we'll call another thing dv. Now when we get our u, we'll take the derivative. When we get our dv, we're going to integrate to get our v, and then when we place it there. So it's not as hard as it looks, okay? So let's do the example we were looking at. We were integrating, let's see, it was x e to the x dx. And we decided we could not integrate by substitution, so we're going to integrate by parts instead. So for this particular problem, I'm going to say we want a u dv. I'm going to say let u equal x. So I go off to the side and say u is x. Now if u is x, du, take the derivative, is just dx, or 1 times dx, if that helps, just to write 1 times dx, all right? So if we declare u to be x, then that means dv, because here's our u, there's our dv, we're going to declare that to be e to the x dx. E to the x dx will be our dv. All right? So now from our dv, we have to integrate to get to v. Well, integrating e to the x is very easy. It's just e to the x. Okay. So now we're going to apply our formula. We're going to say it equals u times v, where there's our u. There's our v. Now, it's just by coincidence it happens to be this. That is not the case all the time. We're just following the formula. Minus integration of v, v is e to the x, du, du is 1 times dx, which we could just write dx. That's fine. This is all times. Okay, now from here, we just go ahead and bring this x to the ex, that's this right here, and we're going to integrate this. We keep our negative sign, we integrate e to the x, and what is the integration of e to the x? Just e to the x plus c. All right? So we are done. Now how could we check our answer? The way to check our answer is to take the derivative of this, and you'll see we will get that. So let's check and see if that works. Okay? So here we would take the product rule. Being this, I'm going to call this f of x and this g, and let's do the product rule. The product rule says that we keep f the same. We take the derivative of g, which happens to be e to the x. And the product rule says we add, take the derivative of f, which is 1, and then we take the derivative of e to the x. We just take g, which is e to the x. Okay? The derivative of negative e to the x is just negative e to the x. The derivative of c is 0. Okay? So let's keep going. Well, we have x e to the x. Look at here. We have a positive e to the x and a negative e to the x. So all this goes away, and there's our answer. All right, so it worked. Okay, let's do another problem. I'm going to erase this one, and I'm going to erase these so that we can rewrite in these. Okay, so you can still see the formula. All right, so here's another one we're going to do. Another example. We're going to do x squared ln x dx. Okay, now when it comes to these logarithms, generally we let u equal the logarithm. So there's a little hint that'll save you some time. So we're going to let u equal ln of x. Okay, so what does that mean dv is going to be? We found our u. dv is going to be these two, x squared dx, because that's what's left. All right, so now we take the derivative of ln of x, which is 1 over x, and now we're going to integrate x squared. We add 1 to the 2, which gives us 3, and divide by 3. Okay, we don't put r plus c. So here's what we're going to use to apply to our formula now. See, it's not that bad. U times v, u is ln x, times v. V is x cubed over 3 minus the integral of v. V is x cubed over 3 times du. du is 1 over x. Okay, we're missing a dx. Where did the dx go? I forgot it right here. See? I needed to put that dx there. Okay, so we can continue now. This doesn't really change, so I like to have my ln x second, so I can just write this in the beginning. I don't need any parentheses. Called a little lazy there, right? But that's okay. Okay, so now if we to simplify this, I'm going to bring out the 1/3. This 3 right here, I'm going to bring it out. Then x cubed over x is x squared dx. Okay, so let's continue on this problem. We have x cubed over 3 ln x. We're going to integrate x squared. So I keep the 1/3. I'm going to add 3 to 2. And then I'm going to multiply by the reciprocal. The same thing as dividing by 3. And then we write plus c. Okay, so our answer is, let me write this again, x cubed over 3 ln x minus x cubed over 9 plus c. And there's our answer. All right, now I'm going to give you a problem to do, okay? And we'll go on to the next tape to see how you did. So here's your problem to do. Integrate x ln x dx.